Good afternoon, attendees. This is the 2019 SDG&E Annual Electric Reliability Town Hall, and we'd like to take this opportunity to welcome everybody to our town hall. Our hope is that we will be able to inform you, our customers, about the ways that electric service reliability is measured, managed, and improved upon. We will have some time reserved for questions and answers, and we would like to draw your attention to the Q&A submittal button at the bottom of your screen. And if questions or comments come to mind during the presentation, please submit them at that time, and we will gather those up and address them at the end of the presentation. We do have some time reserved just for that, for Q&A. All right, so also, if you have a question about the reliability of service to a particular home or business, that's not generally going to be something that we can answer today, but we will be able to direct you to a link from the sdge.com website where you can submit a formal inquiry. And this is something we do quite often when customers want to get a record of recent outages to, again, their home or business. We do that as a matter of course in our business. All right. However, any questions of a more general nature, we'll be happy to address those during the Q&A session. All right. The next slide will show what's known as the classification of assets, which is a fancy way of saying this is how utility grids are built. And although the grids are evolving to a more distributed architecture, the electric grid still remains largely a vertically integrated arrangement with central plants supplying major load centers through a network of transmission lines, substations, and distribution lines. The main difference is that now some of those central plants derive their output from renewables, such as wind and solar. Solar is especially popular here in California. The count of individual customer-owned and operated solar systems, the so-called net energy metering systems that are live on the SDG&E system, now tops 200,000, which is about 13% of our customer base. So that's become a significant part of the resource mix, and it's there when the sun shines, and of course, this being Southern California, that is most days. There's also an installed base of larger so-called merchant-owned and operated renewable plants that include both solar and renewables, solar and wind, and that can push our net renewable content well beyond 50% on many days while the sun is out. Most electric service interruptions occur due to events on the distribution system. So that's what you see on the third column from the left on this diagram, the distribution side. There's generally a lot more exposure for distribution to be subject to problems of one kind or another. So most outages are a result of impacts to the distribution network. Occasionally, transmission events can cause outages, and generation-related outages have actually become so rare they're no longer really tracked anymore. Like anything else, we have to look at reliability. We have to have a way to measure reliability, and toward that end, our goal as a provider is to provide our customers with safe and reliable power, improve reliability by reducing the number of outages, their duration, as experienced by our customers. We review all our outages and causes, validate trends that may surface, and we work to mitigate for issues that we are able to identify. There are a total of 4 metrics that are used to measure this performance, this electric reliability performance. The first metric is known as the System Average Interruption Duration Index, or the SAIDI. And just like it says, it is a look at the average outage time experienced by customers. And you'll see in some subsequent documents that we'll share that this SAIDI index, typically for the SDG&E system, barring major events, runs anywhere from 50 minutes to 70 minutes over the course of a year. The next index that we typically track and record is the System Average Interruption Frequency Index, or the so-called SAIFI index. And this is a measure of the number of times that a customer experiences a sustained outage in a given year. And when we say sustained outage, for our purposes, that means an outage that lasts 5 minutes or more in duration. That's considered sustained. Anything less than that is a momentary, and it has its own measurement. Beyond that, we have the Customer Average Interruption Duration Index, so-called CAIDI, C-A-I-D-I, and this is a measure of the average time required to restore service to a customer once they have been subject to an outage. And finally, we have the Momentary Average Interruption Frequency Index, or the MAFI, and the MAFI is the average number of momentary outages. You'll remember I said momentary outages are outages of less than 5 minutes in duration. They might be just a fraction of a second. They might be 2 or 3 minutes, while some automated switching is working to restore service, things of that nature. Anything less than 5 minutes is considered a momentary outage. Finally, there is the a measure that's used, fortunately, very infrequently, and it's called a Major Event Day, or a MED. And that is a day in which the daily system SAIDI, that's the duration index, exceeds a threshold value. And it's intended to give utilities a way to segregate or categorize days when there are extraordinary events for which it wouldn't be reasonable or economical to try to build the system to tolerate those types of events. We're talking about major Santa Ana wind events or major winter storms. Could be a large earthquake that causes problems, things of that nature. They're significant events. Some examples of our reliability programs, I'd like to talk a little bit about these. Basically, our focus is to build a strategy around an overall system-wide performance to try to manage both the outage duration and the outage frequency. That is, when outages happen, we want to have the ability to restore as many customers as quickly as we can. And furthermore, we'd like to avoid outages in the first place. That's always preferable. First off, we have the so-called FIRM project. That's the Fire Risk Mitigation, FIRM, F-I-R-M. And this is a program that's aimed at fire prevention, safety, and reliability, with a primary focus toward lowering the public safety risk due to wildfires. We want to optimize at the same time reliability improvements. A big part of the FIRM program is replacing the older wood poles with steel poles. At the same time, we take the smaller conductors that may have been in service for some number of decades, and we replace them with larger conductors for a higher level of tensile strength, better performance, and better ability to carry additional loads when the need arises. Since inception, this FIRM project has replaced about 450 wood poles with steel poles, and that puts our program at a completion point of about 30% toward the ultimate goal of a replacement of 1,500 poles. That's the FIRM project. After the FIRM project, we have a very robust vegetation management program, and this includes a systematic schedule-based approach following a work plan to complete all activities annually. This includes a pre-inspection, the actual tree pruning, brush clearing, and other activities. We've been fortunate to be recognized by the National Arbor Day organization 16 years, I should say, in a row, and the Utilities Commission, the CPUC, has considered our program a model for other operators to use. That's vegetation management. We also have the pole risk mitigation and engineering, so-called PRIME, P-R-I-M-E. And this program is aimed at completing a formal strength analysis of all the poles in the SDG&E system, whether they're wood or steel, to confirm that these poles meet or exceed the current standards. We are using contemporary industry-accepted software-based methods to perform these analysis, and also applying industry best practices. That's the PRIME program. Continuing a look at some of our reliability programs, we have the T modernization. Ts are also known in the industry as cable joints, And these are devices that can be used to join two separate runs of large underground cable together so that there is continuous connectivity. However, they are rather limited in terms of how they can be operated for the purpose of improving reliability. A big part of this T modernization program is aimed at upgrading these major connection points on the underground distribution system to help enhance our ability to restore customers when unplanned outages occur. That's T modernization. After T modernization, we have the SCADA program. SCADA is short for Supervisory Control and Data Acquisition, SCADA. And SCADA provides direct operator control of over 2,000 switches across the distribution network from the Mexican border to the probably the Laguna Niguel part of our Orange County district, 2,000 switches, and the operators can open or close these switches on a moment's notice electronically. They will also have access to real-time data in terms of information like load and voltage and so forth, and any kind of fault targeting information that comes back almost immediately through the SCADA system. It's a system that we use quite extensively. Beyond that, we have the business services project coordination. This is basically a customer outreach and outage notification program, including restoration estimates. We know that outage details are, of course, important to our customers. And when the lights are out, everybody wants to know when are they going to come back on? What is the estimated restoration time? So that's the business services project coordination. Next up, in terms of our reliability programs, we have a very robust meteorology group, and they are very adept at forecasting weather and conditions for proactive preparations for adverse weather of all types. And indeed, we had a new department established in 2018 known as the Fire Science and Climate Adaptation, Fire Science and Climate Adaptation Department, to help us focus these combined efforts. I would say that our meteorologists are second to none when it comes to providing the guidance needed to help prioritize where work on the system should be done for best outcomes, as well as giving us some real-time weather forecasting data for storm events, including the so-called Santa Anas that are common in our territory. That's the meteorology group and the Fire Science and Climate Adaptation Department. After that, we have a very active, proactive cable replacement program, and this involves the planned replacement of underground distribution cables as a function of their vintage and their recent reliability performance. You should know our new distribution cables are installed with a manufacturer's warranty of 40 years, and the expected service life of the older cables is approximately 30 to 40 years. So given that the underground system really started to grow in a big way after the late 60s, you can do the math real quick and you can see quite a few cables will be reaching the end of their service life and have reached the end of their service life, and this proactive cable replacement program has been active for some number of years. No cable that we can install will last forever. And with the SDG&E system, distribution system being about 60% underground, which is significant, this is a very important program that we continue and we will manage. We have other aging infrastructure in addition to cables, primarily our substations. These are the facilities that you may see in certain neighborhoods that are fenced with a lot of electrical apparatus inside. They typically are stepping the electricity from a higher voltage to a lower voltage, which is safe to distribute into the neighborhoods. These substations from time to time require upgrades where the major pieces of equipment, be it a transformer or a piece of switchgear or a circuit breaker, has reached the end of its useful service life. And in some other cases, we have lower voltage distribution circuits that were commonly installed many decades ago. We upgrade those to a higher voltage for increased capacity and increased efficiency. You can kind of think of it roughly like an upgrade from dial-up access to broadband service when we do that. And just think wrapping up here on our programs, switches, distribution line switches, whether they are overhead or underground, they too have a finite useful service life, and as they reach the end of their service life, we have projects that are aimed at either removing them if we judge that they are no longer necessary for good performance, or we have the option of replacing them to better facilitate quicker restoration times by our crews when we have an unplanned outage. Some strategically placed switches are replaced with automated counterparts. I mentioned the SCADA system, SCADA program a little earlier. If we see that a particular switch which has reached the end of its service life is become a strategic switch, strategically placed switch over the years, we'll consider replacing that with a SCADA counterpart when we do the replacement work. Otherwise, these switches are considered inoperative while they're energized for safety reasons, and as such, their usefulness during that time is reduced in terms of service restoration. So we don't like to have switches out there that are in that mode for an extended time. From time to time, we do have vehicle contacts with our equipment, and we'll take a look at relocating key devices. Could be a fuse cabinet, a transformer, a switch, what have you. We'll take a look at if the device can be relocated to a position nearby to make it less apt to be subject to a vehicle contact. We'll take a look at that. It's not something that's done very often, but if we see a chronic issue at a location, we'll certainly consider that as an option. This last program I think is kind of interesting. Everyone's familiar with the party balloons, the celebratory balloons. Many folks call them Mylar balloons, but they're actually made out of a metallized material. We've been working with the party balloon industry to help develop an alternative material which will be less likely to cause outages when they come into contact with the overhead lines. We've actually funded high voltage tests at a nationally recognized lab to confirm the performance of these alternative materials when they do contact high voltage with high voltage equipment. So far, I can say the results are very good. It could be that the next party balloon you buy, maybe a year or two from now, could be made of this material, but regardless, we implore everybody to please remember to keep all of these balloons inside with a weighted string attached. Do not release them outdoors and allow them to float free, even in areas with underground utilities, because they may go up in the air for a while and then the helium will leak out and they'll lose their buoyancy and they'll come down, and the chances that they'll come down on top of some overhead lines and cause another outage. They can cause minor outages when they contact the lines. They can cause major outages with significant equipment. It all just depends on a lot of different factors. Okay, so that's the non-conductive balloon development program that I think is one of our most exciting and interesting programs. There are some accomplishments I'd like to boast a little bit about here for the company, awards and recognition. PA Consulting is a leader in utility and energy consultation services, and they are also in a position to offer a number of recognition awards for utility operators. And we have just been the most recent recipient of the Outstanding Reliability Award, Best in the West, for 15 consecutive years. We just learned about that a few weeks ago. In 2018, we were fortunate to receive Best in the Nation Reliability, and that is certainly an award that we aspire to every year if we can get it. There's some tough competition, but that's Best in the Nation for 2018. 2020, we also received the Outstanding System Resilience Award. And that's a recognition of how well a particular operator's system can tolerate different contingencies of one kind or another. And finally, we received the Outstanding Technology and Innovation Award for these 4 years, 2016, 17, 19, and most recently 2020. In 2018, we were fortunate to get the Edison Electric Institute, the Edison Award. Edison Electric Institute, EEI, is an organization of investor utilities in the United States. And also SDG&E was stated as the best investor-owned utility in California in a 2016 CPUC report. All right, so you've heard about our programs and you've heard about some of our accomplishments and awards. And here's the part of the session where we will discuss how electric service reliability is actually measured and tracked. And these measurements are common across not only the state of California, but across the utility industry as a whole. And this next display, this next chart is simply a bar chart, as you can see, that shows the 5-year SAIDI, that's the duration index, the 5-year SAIDI reliability measure for the 3 large investor utilities in the state. That's ourselves, Southern California Edison, and Pacific Gas and Electric. And from this, you can see that SDG&E maintained a first place position for every year except 2018. In 2018, we came in a very close second to Southern California Edison. So this is something we really take near and dear to our hearts here in terms of how are we performing relative to our peers here in the state of California. This is a comparison of SAIDI. The next slide is a comparison of the SAIFI comparison. You remember this is the frequency index, system average interruption frequency index, again for the last 5 years, and the same color scheme here with the 3 IOU utilities in the state. And the good news here for us is that we're in first position each of the 5 years. We've had superior performance in this regard for quite some time. And this may be due to the fact that a higher portion of our distribution system here in San Diego is of underground configuration as opposed to, as compared to some of the other utilities that have a greater percentage of overhead distribution in their systems. The annual report, the 2019 annual reliability report, which I understand is already posted to the sdge.com website. This slide will give you an idea of what to expect. When you see that, there's a total of 9 sections, and depending on the kind of information that you're really interested in, you should be able to find it in any one of these sections. I believe this is our first reference in the slide deck to the IEEE. And the IEEE is known as the Institute of Electrical and Electronics Engineers. It's basically an international professional organization for individuals that work in the electrical engineering disciplines. And one of those disciplines is power engineering. That's our area. Section 1 of the report is a rundown, if you will, of the last 10 years historical performance for SDG&E. To the left, you see the major event days that are included, and this will be found in the full report along with charts and graphs that provide a more illustrative, intuitive view of the data. I might direct your attention to the year 2011. And if you lived anywhere in our service territory in September of 2011, you might remember the 2011 Southwest blackout when the service to all of our customers was interrupted, along with all the customers of the Imperial Irrigation District. That's the next utility to the east in the Imperial Valley, and actually a portion as well of customers in Arizona and on the Arizona Public Service system. And although we had, I believe, all or most of our customers restored within about 12 hours, still the SAIDI figure was astonishing, nearly 568 minutes. And so that was significant. That's an example, an extreme example of what we call a major event days. The most recent years, 2017, 2018, 2019, are still noteworthy in that they all have triple-digit numbers. And I believe this is chiefly due to the severe Santa Ana episodes, which always occur or usually occur in the fall. If we exclude these major event days, you'll see that data on the right-hand side where it says MED excluded. And you can see that throughout the years 2010 to 2019, our SAIDI performance typically runs anywhere from 50 to 70 minutes, just with a couple of exceptions there in some of the latter years. Okay, so this is system indices for the past 10 years, and this is a part of the report that's posted online. Section 2 will include a rundown of the same indices, MAD included, MAD excluded, by each of our operating districts in our service territory. So the SDG&E service territory is divided into 6 operating districts. We do track the reliability statistics in aggregate, and we also track them on a district-by-district basis. And this is in part in recognition of some of the unique operating challenges that each one of the districts face. Some districts are more coastal, some are more inland and mountain, some are more urbanized. So this particular table is for our Eastern District, and the Eastern District extends from roughly the Imperial County line west to, I would say, roughly the Interstate 15 freeway, and it's in the southeast sector of our service territory, all within San Diego County. So you'll see similar tables to this one for the other 5 operating districts, and no doubt there will be differences in the performance, and some of these differences are indeed a function of the type of topology that the districts operate in. Again, some of them are coastal, some will be more urban, and some will be more rural, inland, and mountain, and they all have their own types of challenges. All right, section 3 will provide a detail of the planned and unplanned outages. So from time to time, we do have the need, and maybe some of you in the audience have received a notice from the company at some point about a planned outage. It may be necessary to be able to safely perform work on the system, perhaps to do an upgrade or to correct a compliance issue that we've discovered as a part of our compliance program. These planned outages occur almost every day, certainly almost every weekday, and sometimes on weekends. We do take pains to try to avoid certain holidays and certain other days that are significant for our customers to try to minimize the inconvenience as much as we can. But this shows a view of including planned and unplanned outages, and this starts from the calendar year 2013, and we've been tracking that ever since. Section 4 is simply a service area map. So the SDG&E service territory includes almost all of San Diego County. There is a small portion to the northeast of the county that is not served by SDG&E. It's served by the Imperial Irrigation District. You see that notch on the eastern boundary. And then we also pick up the southern portion of Orange County up to about South Laguna Beach and the community of Laguna Niguel, that's South Orange County. In all, it's about 4,100 square miles, and it's roughly the size of the Big Island of Hawaii, if you want to compare it to something else. Each one of our operating districts is shown here. Each operating district territory, sub-territory, if you will, is shown in a different color. And the Eastern Territory that we talked about earlier, you can see Eastern Operating District there next to the red star, and the color, whether it could be kind of a rust or an orange color, that's the boundaries of our Eastern Operating District. The Beach Cities District is the smallest, most dense of our operating districts. The Northeast District is by far the largest geographically in terms of territory that they cover. But in all, there's 6 operating districts within the SDG&E system. That's section 4. Section 5 is a detail of the so-called worst performing circuits, WPC, and this excludes the major event days. While most of our distribution circuits actually perform admirably, there's always a few that are going to need some help. So we track these outliers, the so-called worst performing circuits, and we review the outages and their causes to determine what corrective measures might be effective to improve their performance. Most of the circuits on this list are in more rural areas. You'll see the districts eastern and northeast are pretty well represented. And so those lines are predominantly of overhead construction, and they have more exposure in terms of circuit miles. and it can be significant. There's one circuit in particular I would draw your attention to, circuit 445. It's got over 100 circuit miles on that one particular feeder that we operate in our eastern district. So that can be significant in terms of managing it during a contingency situation. One of these circuits is from a more urban setting, and that's the circuit CE1 in the Metro District. And what we have there is equipment that has begun to meet the end of its normal service life, and indeed we have replacement work already underway to get that resolved and return that circuit to a more satisfactory mode of performance. Again, most of these circuits that you see on this list will be in the eastern and northeast circuits, in the northeast and eastern districts where most of the rural areas exist. Section 5. Section 6 includes an overview of the top 10 most significant outages. And so here on this display, we can see the impact of the most extensive outages during the 2019 calendar year. You can take note of the 2 cases where a party balloon came in contact and caused outages at major substations, interrupting service to thousands. We can't emphasize enough how important it is to keep the celebratory party balloons indoors, and if they're going to be outdoors, they need to be on a weighted string and not allowed to float free. The outages that they cause can be significant and affect literally hundreds of customers, if not thousands. Also take note of the impact of the red flag warning days, where we have the higher winds, and some of those unfortunately can span multiple days, and the winds can conspire with dryness and really increase the fire risk. These actually ranked 1st and 9th on the list. And I can say the substation outage that was due to the bird contact on November 12th, that has already been addressed with the installation of some custom coverings to the major energized components to help reduce or possibly eliminate a recurrence of that outcome of a bird contact in the substation. Section 7 is includes a look at MEDs by days, and this particular look is looking at the major event day of October 24th, 2019, and we take an hour-by-hour snapshot, if you will, of the number of customers affected. This is one of the PSPS episodes that we endured last fall. And you can see that this was one of the more significant PSPS events. Overall, we have hour 0 to hour 66, and after 66 hours after we commenced operations, we were able to get all of our customers who had been affected by this. We were able to get them all back on the grid. Section 7. Section 8 shows how we track the outages with the largest impact during the last 10 years. It's probably no surprise that these regional red flag warnings, where the high winds are a factor, have caused their share of larger events. And again, you see the bird contact of November 12th, which was addressed with the new coverings. And this is a technique that we've actually utilized at other substations as well. To try to continue to make improvements and install that equipment strategically to help avoid the impact of animal contacts, be it birds or squirrels or what have you. Section 8. Section 9. You as a customer, you can make a formal inquiry about the reliability of service to your home or business. I talked about this a little bit at the beginning of the presentation. So if you want to do that, you go to sdge.com/system-reliability. sdge.com/system-reliability. And you can submit a request, again, whether it's your home or your business, and we will reply back to you with a record of what the outage history has been, and we'll do our best to answer any specific questions you may have about the service reliability to your particular address of concern. We do maintain a significant profile on many of the popular social media platforms, so you can choose your favorite platform and contact us as is convenient for you. And we also have a number of customer engagement channels, and there's many ways that we reach out to you, our customers, and you can reach out to us. Anything from a good old-fashioned phone call or a letter to a live chat, a text, or any of the social media platforms where we maintain a presence. There are a number of tools that our customers can use to get information, right? Like I said earlier, everybody wants to know when the lights will come back on. When can we continue our lives? We have real-time outage maps online from apps for using your favorite device, or online if you find yourself a PC or a Mac. You can look up this information in real time and get information on the cause of the outage as it's known in real time, the circuit affected, the start time, and the estimated restoration time. There's also a video posted online that discusses some details about outages to improve your understanding of the basic steps that we go through to restore service. We know service restoration is important to everybody. So some of the topics or the topics that we discussed today, we started out with a classification of assets, kind of a description of how the utility grid is built in a vertically integrated manner, from central plants to transmission to substations to distribution to the individual customer services. We also talked about the handful of metrics that are used, the SAIDI, the SAIFI, and so forth. We talked about our reliability programs and efforts, including firm vegetation management, data gathering, circuit analysis, business services, meteorology, and a number of others. We're very active programs. And we also shared a comparison of the 3 largest IOUs in California in terms of their SAIDI and SAIFI performance. That's ourselves, Southern Cal Edison, as well as Pacific Gas and Electric in Northern California. We continued with we'd like to continue here with the fact that you can pull up the 2019 annual report that's available to you on the CPUC website, and there's a link available right there, and somebody can post the link in the chat box. That might be helpful for our customers. And again, you can also reach out to us on social media, various customer service channels, engagement channels, and we talked a little bit about the outage tools for customers. There is a relatively new app that's available for Apple, for iOS, and I believe Android, and the name of the app is FSCA, and that's short for Fire Science and Climate Adaptation. It's been released in its version 1.0, and I've been told by the developer that in a couple of weeks we should see a FSCA 2.0 version. So there'll be some upgrades to that app. And within that FSCA app, you have an opportunity to look at the outages and see what some of the statistics are in real time or in near real time.